It is permissible to use the same threaded rod to support piping as well as cable tray or conduit. However, it is crucial to consider several factors. Firstly, weight and load requirements are critical. Ensure that the threaded rod selected is strong enough to support the combined weight of the piping, cable tray, and conduit. This must include any additional loads that might be imposed, such as seismic forces if you are in an area where those need to be considered. Secondly, spacing and support intervals matter greatly. Use appropriate spacing and support intervals for both the piping and the cable tray or conduit. This will ensure stability and prevent excessive deflection in the support system. Thirdly, corrosion resistance is another key consideration. Select a threaded rod material that is corrosion resistant. The specific choice should suit the environment in which the support system will be used. Consider the potential for moisture, chemicals, or other corrosive elements. Fourthly, support type must be adequate. Use threaded rods in conjunction with suitable supports. Examples include U-bolts, trapeze hangers, or strut clamps. These are used to securely fasten the piping and cable tray or conduit to the threaded rod. Fifthly, regarding independent supports, while you can use separate supports for the piping and cable tray or conduit, it is often recommended to use a single threaded rod for both. This approach ensures that they remain aligned. It also helps prevent vibration interference between the systems. Sixthly, code requirements are very important. In the United States, NFPA 13, which is the standard for the installation of sprinkler systems, and NFPA 72, which is the National Fire Alarm and Signaling Code, allow the use of threaded rod for supporting piping and cable tray or conduit. This is provided that the rod meets the specified requirements for strength and corrosion resistance outlined in those codes. In terms of best practices, firstly, use a threaded rod with a diameter that is large enough to withstand the anticipated loads. This provides a safety margin and ensures long-term reliability. Secondly, use corrosion-resistant washers and nuts to prevent corrosion between the different components of the support system. This will extend the lifespan of the entire installation. Thirdly, secure the threaded rod properly at both ends using appropriate fixings. This is crucial for preventing slippage or failure of the support system. Fourthly, inspect the threaded rod and supports regularly to ensure their integrity. Look for signs of corrosion, damage, or loosening of connections. By following these guidelines, you can safely and effectively use the same threaded rod to support piping, cable tray, and conduit, as long as you consider the specific requirements of each system. Let's delve deeper into each of these aspects to provide a more comprehensive understanding. Starting with weight and load requirements, the calculation of the total weight that the threaded rod will support is paramount. This involves not only the static weight of the piping, cable tray, and conduit, but also any dynamic loads. Dynamic loads could include the weight of the contents flowing through the pipes, the weight of cables within the cable tray, and any potential snow or ice accumulation, depending on the location. Seismic forces, as mentioned earlier, can also significantly impact the load. Engineers typically use calculations based on local building codes and seismic design standards to determine the appropriate safety factors. The selected threaded rod must have a load-bearing capacity that exceeds the calculated total load by a significant margin to ensure safety and prevent failure under stress. Next, let's discuss spacing and support intervals. The appropriate spacing between supports for both the piping and the cable tray or conduit depends on several factors, including the diameter and material of the pipes and conduits, the weight they carry, and the specific requirements of the relevant codes and standards. Generally, shorter spans between supports result in less deflection and greater stability. However, this also means more supports, which translates to increased material and labor costs. Engineers must strike a balance between these competing factors. It is common practice to consult manufacturers' specifications and engineering tables to determine the appropriate support spacing for specific types of piping and cable trays. These resources provide guidance on the maximum allowable span for a given load and material. Corrosion resistance is another vital aspect. The choice of threaded rod material should be carefully considered based on the environment in which it will be used. In humid or corrosive environments such as coastal areas or industrial facilities, stainless steel or galvanized steel threaded rods are often preferred. These materials offer superior corrosion resistance compared to standard carbon steel. However, stainless steel is more expensive, so the selection process involves weighing the cost against the required level of corrosion protection. Additionally, consider any potential chemical exposure in the environment. Certain chemicals can degrade even corrosion-resistant materials, so it is important to select a material that is compatible with the anticipated chemical exposure. Now, let's examine the different types of supports that can be used in conjunction with threaded rods. U-bolts are commonly used to support pipes. They clamp around the pipe and are secured to the threaded rod with nuts. Trapeze hangers consist of a horizontal bar suspended from two threaded rods. The piping or cable tray is then attached to the horizontal bar. Strut clamps are another option. They attach to a strut channel that is suspended from a threaded rod. The choice of support type depends on the specific application, the load requirements, and the available space. Independent supports versus shared supports is an important point to consider. While using separate supports for piping and cable tray or conduit is possible, using a single threaded rod for both offers several advantages. Firstly, it simplifies the installation process. Secondly, it reduces the number of penetrations in the building structure. Thirdly, it ensures that the piping and cable tray remain aligned, which can be particularly important in situations where differential movement could cause stress on connections. However, it is crucial to ensure that the single threaded rod is adequately sized to support the combined load of both systems. Now let's dive into the code requirements. NFPA 13 and NFPA 72 are important standards in the United States that address the use of threaded rods for supporting piping and cable tray or conduit. NFPA 13, the standard for the installation of sprinkler systems, specifies the requirements for supporting sprinkler piping. This includes the size and spacing of supports, as well as the materials that can be used. NFPA 72, the National Fire Alarm and Signaling Code, addresses the support of fire alarm wiring and equipment. This includes requirements for the size and spacing of supports, as well as the need for seismic bracing in areas prone to earthquakes. It is important to consult these codes and any other applicable local building codes to ensure that the support system meets all requirements. Moving on to best practices. Firstly, selecting the correct diameter of the threaded rod is crucial for ensuring adequate strength and stability. The diameter should be calculated based on the total anticipated load, including static and dynamic loads, as well as any applicable safety factors. Consult engineering tables and manufacturer specifications to determine the appropriate diameter for a given load and material. Secondly, using corrosion-resistant washers and nuts is essential for preventing corrosion between the different components of the support system. Galvanized or stainless steel washers and nuts are typically used in corrosive environments. These materials provide a barrier against moisture and chemicals, preventing rust and corrosion from forming. Thirdly, properly securing the threaded rod at both ends is critical for preventing slippage or failure of the support system. This can be achieved using a variety of methods, such as bolting the rod to a structural member or using a specialized anchoring system. The specific method used will depend on the application and the load requirements. Fourthly, regular inspection of the threaded rod and supports is essential for ensuring their long-term integrity. Inspection should be conducted at least annually or more frequently in corrosive environments. Look for signs of corrosion, damage, or loosening of connections. Any issue should be addressed promptly to prevent potential failures. In summary, using the same threaded rod to support piping, cable tray, and conduit is a common and accepted practice, provided that certain precautions are taken. Careful consideration must be given to the weight and load requirements, spacing and support intervals, corrosion resistance, and code requirements. By following the best practices outlined above, you can ensure that the support system is safe, reliable, and compliant with all applicable standards. The selection of the appropriate threaded rod diameter, material, and support type is crucial for ensuring the structural integrity of the support system. Regular inspection and maintenance are also essential for preventing potential failures and ensuring the long-term performance of the system. By adhering to these guidelines, you can create a support system that is both efficient and effective. Let's further elaborate on the material selection for threaded rods, particularly focusing on the different types of steel and their applications. Carbon steel is a common and economical choice for threaded rods in environments where corrosion is not a significant concern. However, carbon steel is susceptible to rust and corrosion, especially in humid or wet environments. Therefore, it is typically used indoors or in environments with low humidity. Galvanized steel is carbon steel that has been coated with a layer of zinc to provide corrosion protection. The zinc coating acts as a barrier, preventing moisture and oxygen from reaching the underlying steel. Galvanized steel is a good choice for outdoor applications or in environments where there is moderate exposure to moisture or chemicals. Stainless steel is a premium material that offers excellent corrosion resistance. It is an alloy of steel, chromium, and other elements that form a passive layer on the surface, protecting the steel from corrosion. Stainless steel is ideal for use in harsh environments such as coastal areas, industrial facilities, or food processing plants, where there is significant exposure to moisture, chemicals, or salt. The choice of stainless steel grade depends on the specific application and the level of corrosion resistance required. For example, 304 stainless steel is a general-purpose grade that offers good corrosion resistance, while 316 stainless steel contains molybdenum, which enhances its resistance to chloride corrosion, making it suitable for marine environments. In addition to steel, other materials such as fiberglass reinforced polymer (FRP) are sometimes used for threaded rods in specialized applications. FRP is a composite material that is lightweight, strong, and corrosion resistant. It is often used in applications where electrical insulation is required or where there is exposure to highly corrosive chemicals. When selecting a threaded rod material, it is important to consider not only the environment in which it will be used, but also the specific properties of the material, such as its strength, ductility, and weldability. The material should be compatible with the other components of the support system, such as the washers, nuts, and support brackets. Furthermore, it is important to ensure that the threaded rod material meets all applicable code requirements and standards. Now, let's discuss the different types of threaded rod coatings and finishes that can be used to enhance corrosion resistance and improve the appearance of the support system. Zinc plating is a common and economical coating that provides good corrosion protection for carbon steel threaded rods. The zinc coating acts as a barrier, preventing moisture and oxygen from reaching the underlying steel. Zinc plating is typically applied by electroplating or hot dip galvanizing. Electroplating is a process in which a thin layer of zinc is deposited onto the steel surface by an electric current. Hot dip galvanizing involves immersing the steel in a bath of molten zinc. Powder coating is a durable and attractive finish that can be applied to threaded rods to provide both corrosion protection and aesthetic appeal. Powder coating involves applying a dry powder to the steel surface and then heating it to fuse the powder into a smooth, even coating. Powder coating is available in a wide range of colors and finishes, allowing for customization of the support system. Epoxy coating is a tough and chemical-resistant coating that is often used in harsh environments. Epoxy coating is typically applied as a liquid and then cured to form a hard, durable finish. Epoxy coating offers excellent resistance to chemicals, abrasion, and impact. When selecting a coating or finish for threaded rods, it is important to consider the environment in which it will be used, the desired level of corrosion protection, and the aesthetic requirements of the project. The coating or finish should be compatible with the threaded rod material and the other components of the support system. In addition to the material and coating of the threaded rod, the design and installation of the support system also play a crucial role in its overall performance and longevity. Proper design considerations include calculating the load requirements, selecting the appropriate support spacing, and ensuring that the supports are properly aligned and anchored. Installation best practices include using the correct tools and techniques, following manufacturer's instructions, and inspecting the completed installation to ensure that it is safe and secure. Regular inspection and maintenance are also essential for preventing potential failures and ensuring the long-term performance of the support system. Inspections should be conducted at least annually or more frequently in corrosive environments. Look for signs of corrosion, damage, or loosening of connections. Any issue should be addressed promptly to prevent potential failures. By paying attention to these details, you can create a support system that is both efficient and effective.